Today I'm talking about our paper today, updating Maximilian.js for modern JavaScript live coding. Alternatively this, although it's not quite snappy in a paper title, the internet broke our online DSP library, so we rebuilt it for live coding together. So I'll be covering two kind of clear bits of technology today. One is Maximilian.js, which is the coding library, and one which is the McProject.com coding platform. Was it? Okay. So the focus here of what our kind of development was, we were thinking about having a live coded library which favored the working of algorithms on signal processing, so in a sample loop, over the kind of pattern-centric focus of a lot of live coding libraries. And we were also thinking about how we can do networked shared document live coding, because a lot of this was happening during the pandemic where we couldn't really hang out and do gigs together. So we were finding interesting ways to kind of collaborate from our living rooms. So first I'm going to do a bit of a background on what Maximilian is. Some of you may know it. It is a C++ live coding, C++ library for synthesis and signal processing. Mick probably started working on it about 15 years ago, maybe. So originally, as a C++ library, it was designed for both performance and for teaching. So for quick prototyping of complex signal processing, the main, can you see my pointer? Oh, well, never mind. Here's an example bit of code from a JavaScript version. You can see that where the main action happens is in a plate loop. So this is a sample level loop. It runs at sample rate. You're doing stuff, you're updating oscillators, you're kind of moving ramps, you're ticking clocks. What you're returning is signals. So this is happening really quickly. You can think of this as like equivalent to, say, a draw loop, or some, if you're thinking about visual stuff in processing open frameworks or something like that. Sorry, I keep turning away. I'll focus this way. Cool. So whilst not originally designed for live coding, Maximilian does have some useful qualities for that. We would argue that it's a kind of different approach when what you're changing is things that are happening in such a small playback loop. You have this immediate kind of creative possibilities that kind of, I guess, is slightly more akin to maybe modular, with less of the expensive hardware, than your more pattern-based libraries like, say, Strudel or tidal cycles. Also, developing a live coding language from Maximilian is kind of advantageous just because it has quite a wide user base. So having a known API means people don't have to learn a new API. I've highlighted up here, I don't know how well you can see that. Oh, yeah, it's massive. And Mick will thank me for this. I've highlighted the fact that there's 1,500 stars on Maximilian just to demonstrate that historically it does have quite a large user base. So we were kind of keen to not break away too far from that, whilst also piggybacking on its actual kind of usefulness and powerful audio engine. Kind of as an example of this, the live coding project Sema actually used Maximilian as its audio engine underneath, and has been used for multiple live coding projects over the years in kind of a hacky way. So a little bit of an aside on signal processing on the web, as we're trying to do online stuff. I've highlighted the JavaScript and the .com nature of these two things, which kind of why we decided to approach it in this manner. Browsers are great for some things. There's no installation, you just go to the website. Although I did find that Mimic Project doesn't make it past the Great Firewall, unfortunately. It's so highly cross-compatible, works on different machines. It's network positive, it's on the internet, it's designed for networking to work well. So that's great for collaboration and sharing. Interaction positive, we do quite a lot of machine learning stuff, mainly in Python, which is horrendous if you want to build like real-time interactive stuff. It's possible, but it's a pain, whereas websites are designed to be made in this manner. JavaScript has an existing ecosystem of loads and loads of cool libraries for both music, but also visuals and other forms of interaction. JavaScript is also a really simple language. These days, most people, their first language they will learn, especially in a creative computing setting, is going to be JavaScript. So there's lots of positives and reasons to take this approach. Also, there are a few downsides. It's not the native environment for most musicians. Most people use DAWs or maybe other kind of heavy lifting live coding environments like SuperCollider. It's got ever-changing standards. So whilst you don't have to install stuff, the way browsers allow you to have certain permissions changes quite a lot, and high-end audio is a really low priority for this. So what you'll see is actually we had something that worked, and then, we got broke, and we had to do it again. So in order to do signal processing in the WebAudio API, historically they had something called ScriptProcessorNode, which allowed you to access stuff in this kind of sample-level process loop. Unfortunately, this ran on the main thread, which obviously is terrible for live coding if you want to type and process audio at the same time. And they also completely deprecated it in 2021. So this is what happened to us. We had a version of Maximilian that worked on the ScriptProcessorNode. And then we reached a point where basically it got kind of deprecated for us, so we had to rebuild it. So when we were doing that, we thought, why not make it really lean into how we can make it good for live coding and good for sharing and interactive stuff remotely. The solution is something called audio worklets. This was a development from WebAudio where you could have your own audio processing thread. This was great. It's much more powerful, less interference. You just kind of have to work out how to get your live code updates into the separate thread because it is compiled slightly differently. Rather than build our entire kind of refactor it entirely from our own, because we're not sadists, we actually took the developments from Semmer. So Semmer, part of the stuff that they did was they took the Maximilian library and updated it to work nicely with audio worklets, which was amazing. However, for anyone familiar with the Semmer project, its main goal is about writing your own live coding languages, which, whilst an amazing thing to do, anyone who's ever tried to write a parser and like an abstract syntax tree and stuff, even when you try and make it accessible, it's still pretty deep. So it's an amazing thing to do, but it's not necessarily what everybody wants to do. So we thought, can we kind of take that and bring it back into the known Maximilian API? So the second part that we really wanted to focus on was collaborative live coding with a kind of shared document experience. So what I mean by this is we have different coders. They're in different places, or at least on different machines. They're each running their own local version of the code, but they have a shared code base that they all better at once. So there are a number of requirements for this in order to make this work well and not, as you can imagine, there's a lot of room for breaking everybody else's code and things going terribly wrong. So there's a bunch of like kind of design guardrails we put in for a platform and a library in order to make this work well. So we said the environment must have multiple audio streams, allowing updates without affecting existing streams. So again, this is a classic live coding thing. When you've run something and you've kind of sent it off somewhere, you need to be able to then at least stop it or edit it, ideally. And that's kind of even more so when you've got multiple people all working on the same document. Algorithms and symbolic states should occur without any interruptions to the ongoing audio output. This is just a little nod to the fact that in a lot of live coding environments that take the REPL approach, the whole document is updated when you reevaluate the code rather than, say, individual parts of the code in, say, like a SuperCollider style. Obviously, what we wanted to be able to do was to be able to update parts of the document without interrupting the audio output, a kind of key part of live performance. So you kind of want to be able to update your algorithm without, say, resetting an oscillator or any perceivable change in the output. Should maintain audio output even when invalid code is executed. Again, you always want to do this as a bit of a guardrail, but if you're working with multiple people at once, you don't want other people executing stuff and breaking the whole system. So again, we had to be pretty careful about checking stuff before it went in and before it was tried to be executed. It should allow for individual parts of the document to be updated. So here we're looking at partial execution of the document rather than re-execution of the whole document. Again, I might be working on a bit of code. It's not quite finished yet, but someone else wants to update something they've done. If you reevaluate the whole document, it's going to crash. So we just got partial re-execution. Code is kept in sync between performers, and also code execution is shared synchronously between performers. So because it's all being executed on everyone's local machine, not only do you need to update the code base, but when someone re-executes part of that, you need to share that between everyone as well. So I'm just going to go over the library and the platform we made quickly, how we kind of designed something to meet these challenges. So the mimicproject.com is a creative coding platform we've got. So you can write JavaScript code and immediately see the outputs next to it. We've been doing it for a while, and this kind of approach has been adopted by other web editors, including P5.js editor. You can do partial updates, so in a kind of super collider style, you can execute part of the code, select it, and just update that one part of it, for example, the frequency of an oscillator or a whole algorithm. And all of the code execution and code updates are shared between all performers. We have used ShareDB and WebSockets to kind of keep this all in sync. That's a kind of overview of what we've done. I'm not going to go into too much detail of it for time constraints, but it's in the paper, and if you're more interested, come have a chat about the kind of how it's actually implemented. We used it in a bunch of concerts, mainly during the pandemic, stuff like NIME, the Network Music Festival, and found that it worked, had like a really fun, interesting vibe. I'm going to play you an output just to kind of see what this sounded like. So what you saw there is 3 people all updating their algorithms in real time, and Mick also using 3DS to do shaders for the output. Unfortunately, what you only saw there is, since we can only capture one person, you can only stream one person's screen. We didn't quite have, from an audience perspective, you don't quite get that like collaborative experience. One just really like interesting philosophical side point to this is, because you've got local execution, if you're using random numbers, which we often do in algorithmic composition, unless you like specifically seed them not to, the random numbers are different on everyone's computer. So whilst the execution is shared, it kind of brings an interesting kind of like split in like who's getting the kind of same experience. We also have an audience mode that we've not tested kind of scalably yet, where basically instead of streaming, you're taking one person's output and streaming that and doing it in the normal kind of online live coding stuff, you would give people a URL, they all go there, and they all get the live coding updates, and it's executed on their machine. So in that way, everyone's kind of having a unique experience on their own laptop, which is kind of fun. I'm slightly running out of time, so feel free to have a check of the paper for some more details. Thank you very much. Cheers.